Hi, my name is Kevin McKnight, and I'll be going over AppArmor and HTTPS protocols, along with some server options. So this is just a quick overview. We're going to go over AppArmor, then we're going to touch on hardening a Linux server, then Internet Information Services. Then we're going to configure HTTPS with IIS. Then we're going to go over hardening for IIS. Then we're going to touch on Apache, and then we're going to configure HTTPS with Apache, and then we're going to go over hardening an Apache server. AppArmor is a mandatory access control system, or a MAC. It is installed by default on most Linux systems. It uses the Linux kernel to restrict programs to certain resources, and it does this by using what they call profiles. So there are two main profiles we're going to go over, one being enforcement and the other complaint. Profiles in enforcement mode enforce a profile rules and report any violations in the system's log. Profiles in the complaint mode do not enforce any profile rules and just log a violation attempts. With these profiles, there are two main types of entries used in them: path entries and capability entries. Path entries determine what files an application can access, and the capability entries determine what privileges a process can use. So basically, AppArmor assigns different program profiles to determine what files and permissions that program may or may not need access to. Internet Information Services, or IIS, is a web service that hosts websites and web applications. IIS does not come on Windows machine. It must be installed through the control panel or the command line. IIS has its own processing engine that takes care of all requests from the client to the server, meaning that a client would send a request to the server, and then the IIS would process that request and send a response back to the client. So the IIS consists of two layers: the kernel mode and the user mode. While in kernel mode, uh, executed code has complete access to hardware and can run just about any command. Um, this mode is mainly used for trusted processes only because if it were to crash within kernel mode, it could do some serious damage to the system. Now, while in user mode, any code you execute, it's usually just accessing hardware or reference memory. Um, this grants like an extra layer of security against mistakes, and it can recover a lot quickly versus the kernel mode. Okay, so configuring HTTPS in ISS uh, requires us to obtain a server certificate and bind it. So each web server has its own procedure for loading a certificate and binding it to a website. What a certificate is a digital file that contains information about the identity of a server. So it contains like encryption techniques that are used to establish a secure channel to that server. So there are three types of certificates. There are CA signed, domain, and self signed. For IIS, we'll be focusing on the self-signed certificates. So self-signed certificates are commonly used on websites that are only available to users through the organization's network or their LAN. So if you this is because if you communicate with a website outside of your own network that uses a self-signed certificate, you may have no way of verifying that the site issuing the certificate represents the party that it claims to represent. So it could be a little sketchy, and you may be communicating with the malicious party, putting your information at risk. So binding certificate will be the next step, and binding refers to the process of configuring the self-signed certificate to use the HTTPS port 443 on a website. And then the last step, of course, would be just to test the server to make sure your configuration is correct. Okay, so next is just some hardening techniques for IIS servers. So first we have URL authorization, which grants access to a URL within an IIS application based on the user's name and roles versus their server or system accounts. So this makes it easier to restrict content based on groups versus individually, as they can be associated with a server, a site, or application. Then we have isolating or separating web applications, which mitigates the damage that can be done to a system should it become compromised. This also gives you time to isolate the attack and prevent it from spreading to other applications. And last, I suggest the use of a dynamic IP address restrictions, which is used as, which uses a requester's IP address and domain name to determine whether or not to restrict access. And with this function, the IIS can prevent unauthorized attacks. So Apache is a Linux-based open source web server that's configured through config files in which modules are used to control its behavior. By default, Apache listens to the different IP addresses configured in the config files that are being requested. And with the listen directive, Apache can accept and route specific traffic to certain ports and domains based on the specific address port combinations requested. By default, the listen runs on port 80, but Apache can be bound to different ports for different domains, allowing for like many different websites and domains to be hosted and on a single server. Okay, so configuring HTTPS in Apache will require us to follow a series of different commands within the command line. So first we'll need to install SSL, and this will allow us to access the Apache modules for SSL. SSL will be used for creating certificates within Apache. SSL can be used to make a key for our self-signed certificate. And once we do that, the second step will be to override the Apache default configuration in the .htaccess file, which is located in the Apache root directory. Third step is to generate a self-signed certificate. And once you start that process, you'll be prompted for some information such as the country you're in, the state, city, and then the company name. You should end up with a Apache cert and Apache key, if you've done everything in the previous steps correctly. Next, we'll want to add the certificate to the Apache configuration. This can be done by editing the configuration file on the Apache default website. So we'll be adding a virtual host block on port 443, which is the HTTPS port. We'll want to redirect users without a SSL endpoint to SSL. So we can do this by rewriting a rule for port 80 of virtual host, which will allow that redirection happen. And lastly, you just want to make sure you test the server to make sure it's configured correctly. So next is hardening an Apache server, and these are a few couple techniques that I have. First is removing the server version banner. So you don't want to expose what server version you may be using. Um, Exposing that version can make it easier for a hacker to find vulnerabilities through that particular version of Apache. Another technique is disabling the directory browser listing. This makes it so that visitors can't see what files and folders you may have under your root or subdirectories. And last is timing out your value configurations. So the default time in Apache is about 300 seconds, which makes you an easy target for lords attacks or potentially getting DOSed. So you can mitigate this by simply lowering the value to something like 60 seconds.